If you're running your CNC job with a separate file for every tool, or just plain tired of standing at the machine, waiting for each toolpath to finish so you can load the next one, this video is for you. I'm going to show you how I streamline my workflow by using one file per job rather than multiple files, and how I got my machine to actually notify me when it needs me, which gives me the freedom to complete tasks around the shop. So if you like the idea of working smarter instead of harder, stay tuned. Let's start with the foundation. I'm using UCCNC control software, but this applies regardless of the control software you're using. If you're saving a separate file for every toolpath, you already know what that looks like. You load the first toolpath, let it run, wait for it to finish, load the next file, let it run, and wait. 3 tools, 3 files. 10 tools, 10 files. Every transition is manual, and you're not just changing tools, you're changing G-code files each time. For me, every handoff is a chance to load the wrong file, lose my place, or just screw something else up. Not to mention that you have to keep that many files organized. That's a lot of mental energy spent on something that my machine could help me with. I use VCarve, but most all CAM software lets you combine all your toolpaths into a single file with tool change pauses built in. You just have to select that option when you save your toolpaths. But, and this part matters, if you do that, be sure to change how your control software handles M6 tool change commands, or it'll keep right on cutting without stopping and not only ruin your day, but likely your whole job. Ask me how I know. Most control software has an option to pause at tool change and wait for operator input or something like that. Find that setting and make sure it's enabled. In UCCNC, it's called stop spindle and wait for cycle start. Mac 3 has a similar option. If you're not sure where it is, check the documentation for your software. And then, when the machine hits a tool change, it stops and waits for you to swap the bit. When you're done, you just hit cycle start and it picks right back up where it left off. No more loading multiple files, hopefully getting them in the right sequence. Now it's just one file per job from start to finish. If you're not doing this already, tell me why in the comments. I'm curious what's keeping you on multiple files. I know there are valid reasons to work that way, but I suspect for a lot of people, it's just how they learned it, and nobody's shown them a better way. So now you got a single file for a multi-tool job, where the machine stops and waits at each tool change. That's much better, but we still have a problem. Every time the machine stops, it needs you. And every time it finishes a job, it needs you. And if you're not standing right there, you're losing machine time. And like they say, time is money. Think about how many times a day your machine stops and waits. Every tool change, every job completion, and even if it's just a few minutes wasted each time, across the full day, that adds up to a meaningful chunk of time. Time you could have spent making a few more parts, or maybe just got done work a little earlier. So I needed to design a way for the machine to notify me when it needed me, so I could stay productive in and around the shop, or maybe even out in the yard, and still be in the right place at the right time to get full production out of the machine. Most of the time, I can hear the machine running from wherever I am. But sometimes, when it goes quiet, I don't know if it's done or if it's just making finish passes. That's exactly where these notifications earn their keep. Now, I already know what some of you are thinking. And you're right, leaving a machine unattended is bad practice, generally speaking. But this isn't about leaving the machine unattended. There's plenty of jobs that I watch every second of the way. A new file, the first run of the day, or an unfamiliar material. I'm not going anywhere. But on a long proven cycle in wood that I've already run 20 times, the risk profile is completely different. So I make the call based on the job. What the notifications do is extend my leash, not replace judgment. The notifications should only be used as a productivity enhancer, not a digital babysitter. I keep my CNC computer off the internet. Air-gapped, I guess they call it. Except for the occasional license activation or software upgrade. But while I was trying to get things working, I decided to start with the computer online. My first goal was just to get UCCNC talking to my phone. So if you keep your control computer online, the setup for notifications is really pretty easy. And phase one, as I like to call it, is all you'll need to do. The service that makes this all work is ntfy.sh, or Notify. I'll put a link in the description. It's free, open source, and there's no account required to get started. You download the app to your phone, and when you, or in this case, a macro, posts a message to a topic, any device that's subscribed to the topic gets a push notification instantly. And that's it. On the UCCNC side, two macros do the work. The M6 macro fires at every tool change. The machine stops, the macro posts a notification, and your phone buzzes. Go swap out the bit, hit cycle start, and the machine keeps going. And most G-codes will also include an M30 command at the end of the job. So when the job is done, the M30 macro fires and you get notified that the job is now complete. Both macros are available for free at cncfever.com. There's a link in the description. You can download them, drop them in your UCCNC macros folder, and that's it. This same idea could be applied to Mac 3 or other software pretty easy. If your shop PC is online, you're done. That's the whole system. The macros and the Notify service handle everything. Notifications work anywhere that your phone does. And setup takes maybe 20 minutes or so. But if you want to keep your shop PC offline, like mine, keep watching. I keep my shop PC off the internet for a bunch of different reasons. So posting directly to the Notify service from the PC wasn't a permanent solution for me. That meant the next step was getting the shop PC offline and handling the notifications locally. After some research, I discovered that I could use a Raspberry Pi as a local server for my notifications, and that would keep my shop PC offline. Now, there's a bunch of ways of accomplishing this, and some would argue that my Raspberry Pi is overkill just to push notifications to my phone. And they'd be right. I got the Pi 4 because I have other ideas in mind that I want to do and add to it later. There are links in the description for the Pi I used, as well as a much simpler and cheaper option that would work just as well for this task. Now, I had never experimented with a Raspberry Pi before, but this seemed like the perfect project to dive into the rabbit hole. As it turns out, the Notify app actually has a self-hosting option, which is exactly what I needed to get my computer off the internet. So I installed that app on my shiny new Raspberry Pi and changed the IP address in the macro and in the app itself from the Notify service that I had working before to the Pi's IP address. Same setup, same macro, just no internet involved. I set it up, tested it, and it worked great. And I thought I was done. But then I had a realization. What I had set up was confined to my local Wi-Fi now. And local means local. The moment I went outside of reliable Wi-Fi range, the notifications stopped. I'm sure Wi-Fi probably covers most of where I need to be, but probably wasn't good enough. I don't want to be wondering whether I'm still in range every time I step away for a minute. I want it to work every time without thinking about it. So the Pi wasn't the full solution, but it told me exactly what I needed. What I needed was for the Pi to do two things: receive the notifications from the shop computer locally, and then forward it out to the Notify service so my phone gets it anywhere, on Wi-Fi or on mobile data. So that means I have two tasks running on the Pi at the same time. The first task is the Notify server itself, the same one I set up in phase 2 I call it. It runs locally on the Pi and receives the post from the CNC macro over the local network. The shop PC posts it to the Pi receives it, and that part is already working. The second task was to set up a small Python script that runs as a background service on the Pi. The moment a message comes in, it relays it out to the Notify service on the web, which pushes it to my phone anywhere on the planet. Not that I go very far. Oh, that's funny. So the full chain looks like this. UCCNC fires the macro posts my custom message to the Pi over my local network, the Pi receives it, and the forwarding script relays it to the Notify service. My phone buzzes, and I get notified. And my shop PC never touches the internet. The Pi sits next to my router, powered off the router's USB port, and runs 24/7. If I ever lose power, it comes back online as soon as the power is restored. I don't touch it. It just works. If you want me to do a dedicated video walking through the Pi setup from scratch, let me know in the comments. If there's enough interest, I'll make that happen. So, one file for the whole job. The machine calls you when it needs you. You swap the bit, hit cycle start, and go about your work. Your workflow is streamlined, and you don't waste production time because you went to get a refill for your coffee and got distracted. Oh, hey. Sorry, I was just grabbing some coffee. If you have any questions, be sure to drop them in the comments. And if you're still running One File Pro Tool, let me know why. I'd really like to know. If you like this kind of content, be sure to subscribe. I'm documenting all my builds as I go. Oop. Gotta go. My job's done.